so next on our list of Monte Carlo methods is subsampling data for cross-validation. Now, there's different ways to do this, and there are some R functions that will do this, but they didn't have the flexibility that I wanted. So I went ahead and wrote a little function that will split things up. I'm reading in the same data that we just did. In fact, I should really move this down here. It's good to keep your functions up at the top of the file. Okay, and then what you do is just run them once, and now they're added to our global environment, so I don't have to worry about them anymore. And then I can go and load my data, and you'll see this is the same type of data that I was running before with height, presence, and a bunch of covariates. Okay, so the way sample works, and this is really important because it's not only how subsample works, but it teaches a little bit about how we work with functions in R, especially when you want to return multiple items from a function. So that's something that isn't normally supported, but what you can do is you can create a list, and then you can add things to that list and then return the list. This then comes in with a result where you can then pull items out of the list. And notice there's two sets of brackets here. Okay, and that's just the way lists work in this case. We have to go into the list, get the list out of the list, and then go into the list that's inside the list to pull out the training data and the test data. Anyway, this function takes the data and then a training portion and splits it up into two different sets so we can get training data and test data. So if we go ahead and run that, oh, and this is the proportion of training data, so 0.7 would be 70%. And there you can see there's our training data and there's our test data. So hopefully that's a 30-70 split between the two. Okay, so that's a subsample. Now what we really want to do is we want to repeat this over and over again. That's the Monte Carlo piece. And each time we do this, whoops, this is all of the code. So I'm going to remove the stuff that I already have up at the top. Make sure NA omit is in there. Whoops, left out an NA omit. That's important. So that needs to be up here. So read the file, NA omit, subsample, breaking it up, and then we go ahead and start the Monte Carlo part, create a vector for the standard deviations and for the ICs, and then we're going to go into a while loop, similar to the loop we had before. So I've got my index, it's I in this case, I is pretty commonly used. Then while I is less than 10, so we're going to do 10 loops, and notice I start at 0 and then do less than 10. You can set it to 1 and be less than or equal to 10 just as well, either way. And then here's the end of our loop, okay? And we subsample, we get the training and test data, then we go ahead and do the GAM. Now, in later versions of R, I haven't needed to attach and detach, but I've left that in because with the older versions, you'll have to attach and detach the data for R to see the predictor variables. And of course, the predictor variables have to have exactly the same names for the columns, otherwise it's not gonna work. And you can see that we're training here, we're testing here, so that's our prediction. Now we do have to change a couple things here because notice this is max height, and we also have to check our covariates and make sure the names are correct. So here I've got height instead of max height, so I'm going to go ahead and change that to height. And anywhere else I need to change that? Yeah, right here. Here's where I calculate the residuals by subtracting the predicted values from the original values. And notice I'm doing it from the test data because the test data was used for the prediction. That gives me our residuals, and then I can calculate a standard deviation of the residuals and concatenate that into our existing standard deviation vector. And then down here we'll do a summary of that. Oh, and we do the same thing up here with the AICs. Okay, so I still need to check these variables. Sorry, bounce around a little bit. What have I got? Annual percip, min temp, max temp, mean temp. So min temp, max temp, but this should be annual percip. And like I've done before, I'll tend to go through this one line at a time, making sure everything works love it when it prints out red, but it's not actually an error. It's just saying things are masked. Oh, AIC is not found. Oh, I forgot to execute this step. So I've got to make sure both of these are done. So I've got my arrays over here. Arrays, vectors, same thing. Then I should be able to compute my AICs, add it into my array, do my prediction, get my residuals, and add to my standard devs. And there is my first standard deviation. Okay, so it looks like everything is working. Now we can go ahead and run this any number of times. I'm going to run it 10. I really should run it more than that. 50 to 100 is what we find tends to work well. And then we can summarize our AICs. This gives you the quantiles. You can also look at, I think it's just mean, right? The mean of the AICs. There you go. Same with standard deviation, or of course, we can histogram our AICs and see how are they doing. Now, if you do a whole bunch of these, hopefully this starts to approach normal. I'm going to actually run it again because that's not looking very normal. In fact, it's not very many entries. We need more than that. And let's histogram those again. Because I ran it again without recreating the vectors, it went ahead and added 10 more. So I'm just adding 10 more in. Now we should have 30. And hopefully we start to see something that starts to look more normally distributed, right? Because we're injecting error, we would expect the AICs to be normally distributed from normally distributed error. However, that doesn't always occur. Okay, that's it. That's all we need to do our subsampling, and then looking at our performance metrics. And of course, you can not only do this with standard deviation and AIC, but you could do it with any of the performance metrics from any of the modeling approaches that are supported within R. So very flexible approach. Next on our list is noise injection. Noise injection is deceptively easy to do. Okay, so I'm going to go ahead and create a new script. Now, there is a difference here. Notice that my data set is inside of my loop. Okay, and the reason that's the case, so everything else, here's our vector for AICs, here's our count, our loop count. Okay, and I keep changing the name, sorry about that, but any name will work. And then everything else is the same, except we read the file in and do the NA omits every time through the loop, okay? And the reason for that is because of this line right here. Here's where we're inserting normally distributed data. So here's our rnorm function to create some number of normally distributed errors with a mean of 0, standard deviation of 10. And we're adding that into our annual precipitation value. This is where R really shines because of its vector arithmetic ability, that I can just add those together, even though these could be arrays of thousands of items. And then we do our GAM just as we did before. And then we do our AICs and add those to the vectors and summarize them at the bottom. And the only thing I need to do though is I do need to change this path. So I'm going to jump over to my other file and change the path. Okay, and of course we need to check our predictors and make sure they're correct. Sorry, covariates, whatever we're going to call them. Annual precip. Okay, that looks right. And our response is height. That should work. Okay, and again, I'm going to just step through it once without using the loop, which is a good approach to make sure everything's working. Now, of course, I've already run this before I did the video, so don't be surprised if it doesn't work the first time, okay, because I've run it several times and fixed things. All right, so it looks like it's working. Now I'm going to go ahead and run the whole thing. It's going to do this 10 times, and each time it's going to inject noise into the annual precipitation data, or one of the covariates. And it's done, and now we can summarize our AICs, plot them, and do a histogram, and take a look at the impact that's having. You can see that it is changing the AICs, but it's changing it really, really small amount, right? It's like 58,000 and it's changing it by 5. So that's just a tiny percentage. So this is looking really stable. So based on noise injected into our covariate, this one's looking really good. There we did some more. Still, very narrow distribution. We do enough times, it should look fairly Gaussian. And that's it.